Versioning is a critical aspect of software development and DevOps practices. It involves assigning unique version numbers to different states of software artifacts, such as code, binaries, and configuration files. This practice ensures that teams can track changes, manage dependencies, and maintain consistency across various environments. In the context of build and release pipelines, versioning helps in identifying specific builds, facilitating rollbacks, and ensuring that the correct versions of artifacts are deployed to production. This presentation will delve into the strategies for versioning pipeline artifacts, their importance, and best practices. In DevOps, versioning is essential for several reasons. It provides a systematic way to manage changes, ensuring that every modification is traceable. This traceability is crucial for debugging, auditing, and compliance purposes. Versioning also helps in managing dependencies between different components of a system, ensuring that compatible versions are used together. Moreover, it facilitates continuous integration and continuous deployment (CI/CD) by allowing automated systems to identify and deploy the correct versions of artifacts. Without proper versioning, teams may face challenges such as deployment failures, difficulty in tracking changes, and increased risk of introducing bugs. There are several versioning strategies that teams can adopt, each with its own advantages and use cases. Semantic versioning, SEMVer, is one of the most popular strategies, where version numbers are assigned in the format of major.minor.patch. Another strategy is date-based versioning, where the version number includes the date of the release. Incremental versioning assigns a unique, incrementing number to each new version. Each of these strategies has its own benefits and can be chosen based on the specific needs of the project and the team's workflow. Understanding these strategies is crucial for implementing an effective versioning system. Semantic versioning, or SEMVer, is a widely adopted versioning strategy that uses a three-part version number: major.minor.patch. The major version is incremented for incompatible API changes, the minor version for backward-compatible functionality, and the patch version for backward-compatible bug fixes. This strategy provides a clear and predictable way to manage versions, making it easier for teams to understand the impact of changes. For example, a version number of 2.13 indicates that it is the second major release, with one minor update and 3 patches. SEMVer is particularly useful for libraries and APIs where compatibility is a concern. Date-based versioning assigns version numbers based on the release date, typically in the format YYYY.mm.dd or YYYYMMDD. This strategy is straightforward and provides an easy way to identify when a particular version was released. It is particularly useful for projects with frequent releases, such as daily or weekly builds. For example, a version number of 2023.10.01 indicates that the release was made on October 1, 2023. While this strategy is simple and intuitive, it may not provide as much information about the nature of the changes as semantic versioning does. However, it is effective for projects where the release date is a critical piece of information. Incremental versioning assigns a unique incrementing number to each new version of an artifact. This strategy is simple and ensures that each version is unique and sequentially ordered. For example, version 1, version 2, version 3, and so on. This approach is easy to implement and understand, making it suitable for projects where the primary concern is to ensure that each build or release is uniquely identifiable. However, it does not provide any information about the nature of the changes or their impact, which can be a limitation in more complex projects. Despite this, incremental versioning is a reliable and straightforward strategy for many use cases. Choosing the right versioning strategy depends on various factors, including the nature of the project, the team's workflow, and the specific requirements of the stakeholders. For instance, semantic versioning is ideal for projects where API compatibility is crucial, while date-based versioning is suitable for projects with frequent releases. Incremental versioning works well for simpler projects, where unique identification is the primary concern. Teams should consider their specific needs, the complexity of their projects, and the expectations of their users when selecting a versioning strategy. It is also possible to combine strategies to meet different requirements, such as using SEMVer for major releases and date-based versioning for daily builds. Implementing versioning in build and release pipelines involves automating the assignment of version numbers to artifacts. This can be achieved using various tools and techniques. For example, CI/CD tools like Jenkins, Azure DevOps, and GitLab CI/CD provide built-in support for versioning. Scripts and plugins can be used to automatically increment version numbers based on predefined rules. It is also important to integrate versioning with source control systems like Git, ensuring that version numbers are consistently applied across all stages of the development lifecycle. Proper implementation of versioning in pipelines ensures that artifacts are correctly versioned, traceable, and ready for deployment. To ensure effective versioning, teams should follow best practices such as maintaining a consistent versioning scheme, automating version number assignment, and documenting versioning policies. Consistency is key to avoiding confusion and ensuring that all team members understand the versioning strategy. Automation helps in reducing manual errors and ensuring that version numbers are applied uniformly. Documentation provides a reference for team members and stakeholders, ensuring that everyone is aware of the versioning policies and procedures. Additionally, it is important to regularly review and update the versioning strategy to adapt to changing project requirements and industry standards. In multi-component systems, versioning becomes more complex as different components may have their own versioning schemes. It is important to manage dependencies and ensure compatibility between components. One approach is to use a combination of versioning strategies, such as semantic versioning for individual components and date-based versioning for the overall system. Dependency management tools like Maven, NPM, and NuGet can help in managing versions and ensuring that compatible versions of components are used together. Proper versioning in multi-component systems ensures that the system remains stable, maintainable, and easy to update. Version conflicts can arise when different components or dependencies require incompatible versions of the same artifact. To handle version conflicts, teams can use techniques such as dependency resolution, version ranges, and conflict management tools. Dependency resolution involves selecting compatible versions of dependencies based on predefined rules. Version ranges allow specifying a range of acceptable versions, providing flexibility in managing dependencies. Conflict management tools, such as those provided by package managers, can help in identifying and resolving conflicts. Effective handling of version conflicts ensures that the build and release process remains smooth and that the system remains stable. To illustrate the importance and implementation of versioning, let's consider a case study of a software development team working on a complex web application. The team adopts semantic versioning for their API, date-based versioning for their daily builds, and incremental versioning for their internal tools. By implementing automated versioning in their CI/CD pipeline using Azure DevOps, they ensure that each artifact is uniquely identifiable and traceable. This approach helps them manage dependencies, facilitate rollbacks, and maintain consistency across different environments. The case study demonstrates how a well-defined versioning strategy can enhance the efficiency and reliability of the build and release process. In conclusion, versioning is a fundamental aspect of build and release pipelines in DevOps. It ensures that artifacts are uniquely identifiable, traceable, and compatible with each other. By understanding and implementing different versioning strategies, such as semantic versioning, date-based versioning, and incremental versioning, teams can enhance their development and deployment processes. Best practices, such as maintaining consistency, automating versioning, and documenting policies, further contribute to effective versioning. Proper versioning helps in managing dependencies, handling conflicts, and ensuring the stability and reliability of the system. By adopting a well-defined versioning strategy, teams can achieve greater efficiency and success in their DevOps practices.